The Mitsubishi FX is Japan's most ambitious military aviation project since World War II, representing a decisive pivot from reliance on foreign airframes toward indigenous 5th and 6th generation fighter development. The aircraft, currently under joint development with several international partners including the United Kingdom and Italy as part of the Global Combat Air Program or GCAP, is intended to replace the aging Mitsubishi F2 fleet operated by the Japan Air Self-Defense Force JASDF. From its inception, the FX has been designed to address the strategic challenges posed by rising regional threats, especially from China and North Korea. These threats have manifested in the increasing presence of advanced Chinese aircraft near Japanese airspace, and the frequent incursions of foreign aircraft into Japan's Air Defense Identification Zone (ADIZ). The FX is meant to secure Japan's air superiority deep into the 21st century. The origins of the program began in earnest in the mid-2010s when Japan initiated research and development into advanced fighter technologies. This culminated in the X2 Shinshin, a technology demonstrator aircraft developed by Mitsubishi Heavy Industries (MHI) and flown in 2016. The X2 provided valuable data on stealth shaping, fly-by-wire systems, thrust vectoring, and other high-performance features. It was Japan's first stealth demonstrator and served as a springboard for the FX. Key features of the FX include stealth design, advanced sensor fusion, artificial intelligence (AI), enhanced combat management, and compatibility with a wide range of advanced weapon systems, both domestic and allied. The airframe incorporates a twin-engine configuration and diverterless supersonic inlets, as well as faceted surfaces optimized for reduced radar cross-section (RCS). Reports suggest the aircraft will be similar in size to the F-22 Raptor but more advanced in avionics and sensor integration. A signature element of the FX is its emphasis on multi-domain connectivity. The fighter will act as a combat node, capable of operating autonomously or as part of a distributed network of unmanned combat aerial vehicles (UCAVs), drones, and space-based assets. This combat cloud approach aligns with the doctrines emerging in allied air forces such as the U.S. Air Force's Advanced Battle Management System (ABMS). The aircraft is expected to be equipped with a variable cycle engine, likely based on the XF9-1 prototype engine developed by IHI Corporation. This engine produces approximately 15 tons of thrust with afterburner and is designed for high performance at both subsonic and supersonic speeds. It incorporates features to reduce infrared signature and improve fuel efficiency. The engine also includes embedded power generation capabilities to support directed energy weapons and high-output sensors. In terms of avionics, the FX is set to feature a gallium nitride GaN AESA radar, developed by Mitsubishi Electric. GaN technology allows for higher power and greater thermal efficiency, improving detection range and resolution. Coupled with electronic warfare capabilities including digital radio frequency memory (DRFM) jamming, the aircraft will be capable of operating in contested electromagnetic environments. One of the more revolutionary aspects of the FX program is the proposed use of an integrated fire control system that combines onboard and off-board sensor data to generate a comprehensive battle picture. This will be supported by AI-assisted decision-making, allowing the pilot to manage complex engagements with greater speed and accuracy. Japan has also indicated interest in deploying directed energy weapons, such as high-energy lasers, for missile defense and close-range engagement of airborne threats. Although these technologies are still under development, the FX is being designed with sufficient onboard power and cooling capacity to support their eventual integration. Another defining feature is the FX's potential control over loyal wingman drones. These semi-autonomous unmanned systems will act as force multipliers, extending the fighter's sensor reach, carrying additional munitions, or engaging enemy defenses in high-risk environments. Japan is pursuing several UAV programs in parallel, ensuring that the FX can operate as the core of a larger aerial ecosystem. Structurally, the FX incorporates materials that enhance radar absorbency and reduce maintenance requirements. Its internal weapons bays are configured for stealth operations, and it is expected to be compatible with Japanese-developed missiles like the AAM-5B and the long-range ASM-3, as well as potential integration of foreign munitions such as the Meteor air-to-air missile and Joint Strike Missile (JSM). Japan is collaborating with BAE Systems, Leonardo, and Rolls-Royce on the GCAP framework to share costs, technologies, and production benefits. This collaboration is especially significant as it merges three advanced aerospace industries under a unified development path. While the United Kingdom had originally been developing its own 6th-generation fighter, the Tempest, and Italy had its interests in the same platform. The unification with Japan's FX program allows for cross-pollination of ideas and resources. The timeline for the FX envisions a prototype in the late 2020s, with production slated to begin in the early 2030s. The JASDF expects full operational capability (FOC) by the mid-2030s, ensuring the platform replaces the F2 before obsolescence degrades the force's deterrent power. Japan's defense industry faces multiple challenges in developing such a sophisticated platform. One of them is maintaining cost control and scalability. With estimated program costs exceeding $40 billion, efficient development is critical. Japan's government has committed a large budget, including substantial funds in the 2024 and 2025 defense allocations, but political and economic pressures may still influence program milestones. Another concern is maintaining technological sovereignty while engaging with foreign partners. Japan insists on retaining control over certain core systems, such as the mission computer and sensor fusion software, to ensure independent modification and upgrade paths. This stance aligns with Japan's strategic culture, which emphasizes autonomy in critical defense capabilities. The FX project is not just about air dominance, it's also a means to revitalize Japan's domestic defense sector. After decades of limited exports and production under license from the U.S., Japan sees the FX as a test case for re-establishing its place in the global defense industrial base. Furthermore, the success of the program may lead to opportunities for defense exports to trusted allies in the Indo-Pacific and Europe. Geopolitically, the FX signals Japan's intent to take a more active role in regional security. The Japanese constitution's pacifist Article 9 has traditionally limited its military development to defensive capabilities. However, the evolving security environment has led to reinterpretations of this posture, allowing more aggressive defense planning. The FX embodies this shift, projecting deterrent power and strategic depth. In addition to its operational roles, the FX will serve as a testbed for future aerospace innovations. Japan is investing in research across quantum radar, artificial intelligence, space-based communications, and hypersonic countermeasures. These future technologies may not be included in the initial production batch but are expected to be incrementally integrated through block upgrades. The program's digital engineering approach is another crucial aspect. From the outset, Japan and its partners have embraced model-based systems engineering (MBSE), digital twins, and advanced simulation environments to reduce risk and improve design iteration. This mirrors approaches used in programs like the U.S. Next Generation Air Dominance (NGAD) initiative and ensures faster, more agile development cycles. On a tactical level, the FX will fill multiple roles: air superiority, deep strike, electronic warfare, and command and control. Its long range and high survivability will allow it to operate over the vast maritime domains of the Indo-Pacific, supporting Japan's defense of remote islands and contested waters. It is also expected to interoperate with U.S. platforms, including the F-35, P-8 Poseidon, and Aegis-equipped ships, creating a seamless allied combat network. From a strategic doctrine perspective, the FX may enable Japan to move beyond the traditional point defense posture. With extended range, aerial refueling capability, and network-enabled operations, the JASDF can project power outward, conduct preemptive ISR missions, and support coalition air campaigns. It is important to note that the FX is not being developed in a vacuum. China's J-20 and potential 6th-generation fighter programs, along with Russia's Su-57 and Su-75 projects, create a highly competitive future air combat environment. Japan's decision to develop the FX stems from an understanding that technological parity, or superiority, is essential to deterrence in this environment. At the same time, the FX could serve as a symbol of Japan's soft power and technological prowess. Success in the FX project would demonstrate the nation's ability to lead in cutting-edge aerospace development and contribute meaningfully to global security architecture, especially in conjunction with like-minded democratic nations. The FX is also intended to be future-proofed through modular design. This includes open architecture avionics and plug-and-play sensors, allowing the aircraft to evolve as threats and technologies change. This ensures the platform remains effective for decades and avoids the obsolescence challenges faced by earlier fighter generations. As Japan continues this journey, it will need to balance transparency with security. While partnerships and information sharing are key to success, protecting critical technologies from espionage or proliferation is vital. This is especially critical given the increasing cyber threats faced by high-tech military projects. If successful, the FX will redefine the capabilities of the JASDF, elevate Japan's standing in aerospace innovation, and contribute to a more balanced power structure in the Indo-Pacific. The aircraft is more than a fighter, it is a strategic statement, an industrial catalyst, and a cornerstone of Japan's defense policy in the 21st century.